Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that has completely transformed the world of software development. You've probably heard the term thrown around, but what does it actually mean? Is it a job title? A tool? A new programming language? Well, stick around, because by the end of this video, you'll have a crystal clear understanding of what DevOps is, why it's so important, and how it's revolutionizing the way we build and deliver software. So, let's start with a classic scenario. Picture this. You have two teams. On one side, you have the development team, or devs. Their main goal is to write new code, create new features, and push updates out as quickly as possible. They thrive on change and innovation. On the other side, you have the operations team, or ops. Their primary job is to keep the system stable, reliable, and secure. They're cautious about change because any new update could potentially break something and cause a major outage. Can you see the conflict here? The devs want to move fast and introduce change, while the ops team wants to maintain stability by minimizing change. This traditional setup often created a huge wall of confusion between the two teams. Developers would finish their code, metaphorically throw it over the wall to the ops team, and say, "Here, it works on my machine. You figure out how to run it in production." The OPS team would then struggle to deploy this new code, often running into issues they had no context for. This led to finger-pointing, delays, long nights, fixing bugs, and a lot of frustration for everyone involved. The entire process was slow, inefficient, and stressful. This is where DevOps comes in. DevOps isn't just a tool or a title. It's a cultural philosophy, a set of practices, and a collection of tools that aims to break down that wall. The core idea is to merge development and operations into a single, cohesive unit. Instead of being two separate teams with conflicting goals, they work together throughout the entire software development lifecycle. From the initial idea all the way to production and maintenance. The goal is to create a collaborative environment where everyone shares responsibility for the final product. So, how does this actually work in practice? DevOps is built on a few key principles. The first and most important one is culture. It's about fostering communication, collaboration, and shared ownership. Instead of blaming each other when things go wrong, teams work together to find a solution. Everyone is on the same team, with the shared goal of delivering value to the customer quickly and reliably. This cultural shift is the foundation upon which everything else is built. The second key principle is automation. DevOps heavily relies on automating as many manual processes as possible. Think about all the repetitive tasks involved in software development: compiling code, running tests, deploying to servers, configuring environments. In a traditional setup, these were often done manually, which is slow and prone to human error. A single typo could bring a whole system down. DevOps introduces automation to make these processes faster, more reliable, and repeatable. This leads us to two of the most critical practices in the DevOps world: continuous integration and continuous deployment, often abbreviated as CI/CD. Let's break them down. Continuous integration, or CI, is the practice where developers frequently merge their code changes into a central repository. Every time a developer commits new code, an automated process kicks in. This process automatically builds the software and runs a suite of tests to make sure the new code doesn't break anything. If the tests pass, the build is considered successful. If they fail, the team is immediately notified so they can fix the issue right away. The main benefit here is that you catch bugs early. Instead of waiting weeks or months to integrate everyone's code and then discovering a mountain of conflicts and bugs, you find and fix them in small, manageable chunks. This makes the entire development process smoother and more predictable. Now, once your code is successfully integrated and tested, what's next? That's where continuous deployment, or CD, comes in. Continuous deployment takes CIA a step further. After the code successfully passes all the automated tests in the CI stage, it is automatically deployed to the production environment, making it live for your users. Yes, you heard that right, This means that every single change that passes the test suite can be in the hands of users within minutes. This allows companies to release new features, bug fixes, and improvements at an incredibly fast pace. Some organizations might opt for a slightly different approach called continuous delivery. With continuous delivery, the code is automatically tested and prepared for release, but the final push to production requires a manual approval. This gives the team a final checkpoint to decide exactly when to release the changes, perhaps coordinating with a marketing launch or waiting for a low traffic period. Whether it's continuous deployment or continuous delivery, the goal is the same: to make the release process fast, reliable, and So, you might be wondering, what kind of tools make all of this possible? The DevOps landscape is huge and filled with amazing tools. For managing source code and enabling collaboration, tools like Git are the standard. Platforms like GitHub, GitLab, and Bitbucket build on top of Git to provide powerful features for code review and repository management. For the CI/CD pipeline automation, Jenkins has been a long-time favorite. It's an open-source automation server that you can configure to do almost anything. More modern alternatives, like GitLab CI/CD, GitHub Actions, and Circle CI, are also incredibly popular, offering powerful and often easier-to-use pipeline configurations. Then there's the world of containers. You've probably heard of Docker. Docker allows you to package your application and all its dependencies, system tools, code, and runtime into a single, lightweight container. This container can run consistently on any machine, whether it's a developer's laptop or a production server. This solves the classic "it works on my machine" problem once and for all. And when you have many containers to manage, you need an orchestrator. This is where Kubernetes comes in. Kubernetes is like the conductor of an orchestra for your containers. It automates the deployment, scaling, and management of containerized applications, making it possible to run complex, large-scale systems with high availability and resilience. Of course, once your application is running, you need to know what's happening. This is where monitoring and logging tools are crucial. Tools like Prometheus, Grafana, and the Elk Stack, which stands for Elasticsearch, Logstash, and Kibana, help teams collect metrics, visualize data, and analyze logs. This gives them real-time insight into the health and performance of their applications, allowing them to proactively identify and fix issues before they impact users. By combining this culture of collaboration with this powerful toolchain, DevOps delivers some incredible benefits. The most obvious one is speed. Teams can release software much more frequently, going from releasing every few months to releasing multiple times a day. This allows them to respond to market changes and customer feedback almost instantly. Another huge benefit is reliability. You might think that releasing more often would lead to more bugs, but with extensive automation and testing, the opposite is true. The automated CI/CD pipeline acts as a safety net, catching issues before they ever reach production. And because each release contains only small changes, it's much easier to pinpoint and fix a problem if one does slip through. DevOps also improves security. By integrating security practices and automated security testing directly into the development pipeline, practice known as DevOps, teams can identify and address vulnerabilities early in the process, rather than trying to patch them on at the end. Security becomes a shared responsibility for everyone on the team. And finally, it leads to improved collaboration and happier teams. By breaking down silos and encouraging shared ownership, DevOps reduces friction and frustration. Developers and operations engineers work together towards a common goal, leading to a more positive and productive work environment. No more late-night blame games. So, to recap, DevOps is a culture, a set of practices, and a suite of tools designed to break down the wall between development and operations. It emphasizes collaboration, communication, and automation through practices like continuous integration and continuous deployment. And with the help of tools like Git, Jenkins, Docker, and Kubernetes, DevOps enables organizations to build and deliver software faster, more reliably, and more securely than ever before. It's not just a buzzword. It's a fundamental shift in how we think about creating technology. I hope this overview has given you a solid understanding of what DevOps is all about. It's a massive and constantly evolving field, and we've only scratched the surface today. If you enjoyed this video and want to learn more, let me know in the comments what specific part of DevOps you'd like me to cover next. Maybe a deep dive into Kubernetes or a tutorial on building a CI/CD pipeline? Your feedback helps me create the content you want to see. Thanks so much for watching. If you found this video helpful, please give it a thumbs up. And do you forget to subscribe and hit that notification bell so you don't miss our future videos. See you in the next one.